Hi everybody, today we're looking at composition of functions. And the easiest way to understand composition of functions is it's basically a mashup of two functions to make a new function. So the process that we're going to have to look at, or the process we're going to have to remember when we did functions, is whatever replaces x in the f of x is going to replace x in the expression. So if I take f of x as a quadratic, x squared plus 5x plus 6, then f of 2's replaced x in f of x, so 2 will replace x in the expression. So I get 2x squared plus 5 times 2 plus 6, which is 4 plus 10 plus 6, which gives me 20. Now when we were doing odd and even functions, we were working out what f of negative x is. So negative x replaces x here in f of x, so it replaces x in the expression. So I'll do that, and then I get negative x squared, which is just x squared, plus 5 times negative x, which is take 5x plus 6. And then 4x, well 4x is going to replace the x, so it'll be 4x squared plus 5 times 4x plus 6, so that'll be 16x squared plus 20x plus 6. And here all I've got is just a new function. F of 4x is just a function. So what about if I actually had two functions originally? I had g of x equals the square root of x, and I had f of x as defined above. Well, g of x is replacing the x in f of x, so it'll just replace the x in the expression. So instead of having x squared plus 5x plus 6, I'll have g of x squared plus 5 times g of x plus 6. Now g of x squared is just the square root of x, so I'll put that in place of g of x, because there may be able to be some simplification I can do. So the square root of x squared is just x, so it'll be x plus 5 times the square root of x plus 6. And this is what we call the composition of f and g, and it's shown as f circle, we call this circle, or circ, g. Now, often this second type of notation gets a bit confusing. But it's important to understand that the order is the same. So if the function is f of g of x, then it will be f circle g. So f circle g is just f of g of x. What about g circ f? Well, the order is the same, so that will be g of f of x. And then in g of x, which is the square root of x, well, f of x has replaced the x in g of x, so it will replace the x in the expression. So it'll be the square root of f of x, which is the square root of x squared plus 5x plus 6, and there's no simplification I can do on that. These terms are added, so I cannot split the square root. I can't say that. So that's not the square root of x squared plus the square root of 5x plus 6. Because they're added, I can't split the square root. So let's have a look at a visual demonstration of what a composition of functions is actually happening. So if we're taking f of g of x, the first one we did, well in here we've got x, and then it's g, then it's f. So g is applied to x first, then f is applied to the values that come out when we apply g to it, or to the values we get when we've applied g to it. So g gets applied first, and then we apply values of f to those values that have had g applied to them. So g gets applied, then f. Okay, so the domain of g of x is just x greater than or equal to 0. We can only put positive values underneath the square root. And that's what I've shown in this circle here. Now the lowest value we're putting into this composition is x equals 0. Now when I get x equals 0, and I apply g to it, in other words I square root it, I get 0. Then if I substitute that value into f, I substitute this value of 0 into f, I get 6. So for f circle g of 0 is equal to 6. Let's take another example. What about 4? When I apply g to 4, notice I'm just taking the positive square root, so I'm going to get 2. It's okay. And if I apply 2 to f, well, I'm going to get 2 squared plus 5 times 2 plus 6, which we worked out before as 20. So f circle g of 2 is 20. Now, this shows us some key things about the domain and range of this composition. The domain can only include values in the domain of G. In other words, the domain of my composition will never include values outside the domain of G, the one that's being applied first to x. Because remember, part of a function is we actually have to get a y value for an x value that we put in. So I'm not going to put into my domain x values that are going to give no y value. Now the range of f composed with g can only include values in the range of f. Because I can't apply f to real values and get something that's not in the range of f. The range of f is limited in what it can give me. It will only ever give me values in its range. I'll never get values outside the range. Now the range of g of x is where it gets interesting. So the range of g of x must only include values that are in the domain of f. You see, if I get a value out of g of x, and f of x is not going to make, and it's not going to give us a y value when we plug it into f of x, well that's not a function. You see, remember, for a function, every x value we put in has to have an associated y value that comes out. So if I've got a value in my domain, and I apply g to it, and then after applying g to it, I apply f to it, but it gives me no y value for f, I'm going to have to take it out of my original domain so that I've got a function. Now we need to have a look at that in a bit more detail, but let's just finish up first of all with g composed with f, the domain and range. The first thing to do is to write down what the domain of both of these functions are. Now, sorry, I've got the order around the wrong way. It's f composed with g. G is applied because it's f of g of x. So let's write down the domain of g. We had that before. That was x greater than or equal to 0. The range of g, well, it was all the positive square root values, so it was y greater than or equal to 0. And then the domain of f, well, the domain of f, you can put any real number into f, and then the range of f, well, it depends on the vertex, because this is a quadratic. So you could justify this to yourself. I won't go through the details, but the vertex of f is at minus 2.5, and then minus 0.5, rather 0.25. So the range of f is all the values greater than or equal to minus 0.25. Now, the domain of g and the range of f. Well, what values can we put in? Well, into this function we can put all the values x greater than 0. So the domain of f circle G is x greater than or equal to 0. The range of f circle G, well, the greatest value or the smallest value we're putting in to f of x is 0. So even though the vertex occurs at minus 2.5, we're not putting minus 2.5 into this function. We're only putting all the values in, we're only putting the values 0 or more into f of x, and they're producing the values of 6 or more. So the range is not the entire range of f, it's only part of the range of f. Let's do another example. Let's do G composed with f. Now I've got the domain of G, I've got the domain of f. So if we were to start off with, into f we're putting all the real numbers. And then in the range, so this is f. Then in the range I'm getting all the values that are minus 0.25 and out. But if I then put those values into G, I'm going to get some wrong, or I'm going to get some values that are missing. You see, all the negatives that I put into G are going to be missing. So here we need to remove all negative values. Because this y greater than or equal to minus 0.25 includes values that are not in the domain of G, and I can't have that. I've got to have x greater than or equal to 0 for G. So in here, I've got to remove all the negative values before I get to applying G. Now, what values are going to give me negative values when f is applied to them? Well, if we think about f of x is equal to x squared plus 5x plus 6, and this equals 0, well, when it's factorized, it's x plus 3, x plus 2. So the zeros are minus 3 and minus 2, and then if we draw the sign diagram, it's negative between minus 3 and minus 2. And it's positive on the outer edges. So when I go back, so I've got to go back to my domain, and I've got to change my domain. So, and I'm just wondering where I should write it, but probably I'll write it down here. So this is all considerations under my domain. So it's changed to x being less than or equal to minus 3, x being greater than or equal to minus 2, and when I apply f to those values, I get y being greater than or equal to 0, and now everything's good. Now I can apply G. So I apply G to it, and I get the range of G just being all the values greater than or equal to 0. So, and I might just call that y of f just to indicate that that is the range of f. Actually, what I'll do is I'll call that y of f is greater than or equal to 0. So then we can go on to x of G, the domain of G is greater than or equal to 0. And then, so my range, y greater than or equal to 0, is the range of my composite function. So the domain of f, what was the order here? It was G composed with f, is x less than or equal to minus 3, x greater than or equal to minus 2, and the range of G composed with f is y greater than or equal to 0. Okay, alright, I'm going to do one more example, just because the first time you see something, it's a little unusual. So, we're going to define two functions. We're going to find g of x negative x squared plus 5x plus 6 and f of x as the square root of x. Okay, now for this one, let's just do one of the compositions, but let's write down the domain and range first. So the domain of g is x of g. So what values would I put into g? Well, I can put all real values into g. Now the vertex of this one, and again you could verify this to yourself, the vertex is I think it's 12.25, but I'll double check that. Now this is that's correct. So now this is a downward facing quadratic, so it'll be all the values less than 12.25. So y of g is less than or equal to 12.25. Now the domain of f, so I can only ever put positive values underneath, positive or 0 underneath the square root sign. And then the range again, because this is the positive square root value, it'll be y of f is greater than or equal to 0. So what I'm going to do now is I'm going to do g composed with f. Rather, let's do f composed with g. So g gets applied first, then f. So I start with my domain being x in the reals. And then under g, that gives me all the values less than or equal to 12.25. That includes a lot of negative values. So to be able to work with x of g being greater than or equal to 0, I've got to remove the negative values. So what values of x are not going to give me negatives? Well, let's work it out. So x squared minus x squared plus 5x plus 6 equals 0 when I'll divide everything by minus 1. And I'll have x take 6, x plus 1. So the values will be 6 and minus 1. Now if I've got a downward facing quadratic, then it will be negative on the outer edges and positive in the middle. So the only values I want are x less than or equal to 6 and greater than or equal to minus 1. Those are the only values that are going to give me positive values when I put them into f. So my domain becomes x less than or equal to 6, greater than or equal to minus 1. I put them into f, or rather g is what I'm working with, and I get a range which is y of g is greater than or equal to 0, which then fits into my domain of x greater than or equal to 0, and then I get values coming out of which are just positive. And so my domain of this composition of g circ f is the values between 6 and minus 1, and the range of g circ f is all the values greater than or equal to 0. And I hope that gives you some idea of how we can use a diagram to work out the domain and range of a composite function, but we will talk about it in class as well.